more costly errors and less costly errors. So it's about going for the least costly error. So it's a different way of looking at it. So very simply here, let's say that you walk in the jungle or the forest, and you know there are some dangerous snakes around there in the forest. And so if we stay in the upper left square here, first quadrant, then let's say that you observe something that looks like a snake, and it turns out that it actually is a snake, and you run, right? You see something that looks like a snake, and you run, and it is actually a snake. So, that was probably a pretty good decision, right? Because if you, that's the next one, to the right, the upper right corner. Um, if if you think, if it's perceived as being a snake, but it is not a snake, so you run, but you shouldn't have run. Yeah, you made an error, right? Because you spent energy running and becoming very scared and running away. Although there was nothing to be afraid of because it was not a snake, it was just a stick that looked, a wooden stick that looked like a snake. And so, of course, the error here would be that, yeah, that's not a very costly error. It is, it is an error, and it is, it does cost you something, but it's not very costly. So let's think about the lower left corner. So let's think about that. Reality is that it is a snake, this dangerous snake, but you don't move and you don't run, right? And it bites you and you die, and you think, or become very sick, and you say, well, that's a pretty high cost, right? So it's much more costly than running, even though was nothing to be afraid of, right? And then finally, the last one is that you don't run and it's not a snake, and of course that's just fine, it's correct. But the idea is here that this type 2 false negative is much, much, much more costly than the type 1 false positive. So therefore, in this situation, if you see something that, that looks like a snake, a dangerous snake, then just run. So that's the essence of error management theory. You can sort of bring it into something that could be more relevant for sort of the modern human being, or here where we don't have any dangerous snakes. That you can see here that let's say you go to a job interview, and those interviewing you at the job interview will not be those that will work with you. So if you get the job, right? Let's say it's some recruiter, or it's some head of HR or something like that, that is interviewing you, then um, is it good to be unbiased? Is it good to just be truthful about your skills and so on? Or is it better to be overconfident, right? To give them the impression that you are better than you actually are, right? And you can say, well, yeah, at least this study, from some years ago, indicated that. I mean, of course, if everything was perfectly rational, it should be a line directly from the bottom left corner to the upper right corner, right? But you can see here it may pay off to be overconfident, and certainly it will never pay off to be underconfident, but it'll certainly it'll often pay off to be overconfident in these situations, especially in situations where they won't actually work with you in your everyday job. I mean, afterwards, after when you've gotten hired. So that's one way of also looking at it, and also one way of criticizing the whole idea about being biased, because in classic sort of cognitive biases, terminology, then being overconfident is also a bias, right? And also underconfident, obviously, but you should sort of keep on that straight line between overconfident and underconfident. So sometimes, or often, it will pay off to be overconfident. And this situation has also been applied to a more entertaining situation. There's this paper called Error Management Theory: A New Perspective on Biases and Cross-Sex Mind Reading. Here we have the two authors where they investigated um, men and women in terms of how good they were at reading each other's minds, right? And of course, this is not clairvoyance or something hocus pocus. Uh, this was um, one of the things they did for this experiment was having men and women watch videos of other men and women interacting and see if they were interested in each other, romantically or sexually interested in each other, those men and women they observed. And consistent with everything we know about evolutionary psychology and biology and everything we know about, the science of human behavior, um, when women watch videos of these men and women interact with each other, uh, they tended to underestimate how interested the women were in the men, right? So while men watching the exact same video tend to overestimate how interested the women were in the men in the videos. So the idea is here, and this is of course again, we have to remember that our biology or the biology of men and women has developed um, way before contraceptives and so on, which is very, very modern. So the idea is in our evolutionary past, uh, a man could commit two errors in this situation, right? Since nature wants to reproduce, right? Genes wants to reproduce. Uh, Biology will, on average, make the men want to reproduce, and so let's say that that he meets a woman and a woman looks at him, and then he would tend to overestimate her interest because that will make him approach her, right? So, and he can commit two errors here. One is less costly than the other. If she's not interested in him and rejects him, right? That's of course a relatively costly error, right? Maybe if there are other people around, that could even, maybe it could decrease his status and so on. He'll get rejected. He spent energy approaching her. He gets rejected. But the other costly error, which in this situation is much more costly, it is to not approach a woman that is actually interested in him, right? Because then he loses the chance of reproduction in this situation. So again, according to error management theory, he should he should choose the least costly error, and that's how they explain in this study. That's how they explain why the men investigated in this study, tended to overestimate the interest of the women they observed interacting with the men, right? Because it's their overestimation that will make them try to approach her because they think that she might say yes, right? So it makes sense that men, right, that men would tend to overestimate the interest of women in them. And on the other hand, from the woman's perspective in this situation, she can also commit two errors, right? Since in the recent evolutionary past, before contraceptives and so on, a woman would could easily become pregnant, right? And that is very, very, very costly, right? You need more calories for a long time. You need more security. There's a lot of things you need. So it will be very smart for a woman in the evolutionary past to find a man that not only has good genetics, but would also where she will also very likely stay with her after she becomes pregnant and continue to provide resources to her. So so it would be a very costly era in the evolutionary past if a woman would uh, get impregnated by a man, reproduce with a man that would leave her instantly, right? So she would be very skeptical of men approaching her and testing them, right, to figure out whether they would actually be there for them in the long term. So while a less costly era, because there'll always be, the idea is, that's also what they write in the paper, the idea is there will always come new men to approach the woman. So if she actually rejected a man in this situation that would be there for her in the long run, that's not such a costly error. That's a less costly mistake than making the other mistake of actually, uh, you know, making that huge mistake of reproducing with a man that will not be there for her in the long term, right? And that's how they explain why women tend to underestimate the long-term interest uh, of the man, right? So so they try, and they had different ways of controlling for other factors, and it was a very clear result, and very much in line with what we know already um, from evolutionary psychology and the biology of human behavior. So quite fascinating that error management theory could be sort of a better way of analyzing decision making situations instead of using this maybe a little bit old fashioned cognitive biases sort of approach. Finally, we move on to social neuroeconomics. And I mentioned in the beginning that many years ago I did a study uh, um, about detecting social cheaters, that we are very good at detecting social cheaters, and it really makes sense that we are very good at it, because if we weren't, then we wouldn't be punishing them. We can only do after we've detected them, and therefore society would degrade. And yeah, so this is one way to go about it. So imagine, yeah, bear over with me because this is actually not a social rule, but it'll uh, it'll be clear in a few slides why I have to show you this first. So below are four cards. There's a letter on one side of the card and a number on the other side. Turn one or more cards that are necessary to check whether the following rule holds. If there is an A on one side, then there is a 3 on the other side. Which card or cards are necessary to turn to check whether the rule holds? And I'll give you a few seconds. Which of these cards would you have to turn to check whether the rule holds? You just have to pause it because I'll give you the answer now. The first one, or one of the cards, is the A card, right? Because you have to check, well, is there a 3 on the other side, right? Uh, that's easy. It's very easy for most of us to choose that card and see that's at least one of the correct cards. And then there's the difficult card, and that's the 7 card. That's the falsification card. Because of course, if there is an A on the other side of the card, then the rule is falsified, then is wrong, right? So this is the other necessary card you have to turn to check whether the rule holds. And a common mistake, which was the same mistake I did the first time I saw it, was also to choose a 3 card, right? Because what if there's a B on the other side, right? Wouldn't that make it, wrong? But no, it wouldn't, because the rule says if there is an A on one side of the card, then there is a 3 on the other side. It doesn't say if there is a 3 on one side of the card, then there is an A, right? So it's only if, and it's actually if and only if there is an A on one side of the card, then there is a 3 on the other side of the card. So this card is irrelevant. If there's an A, if there's a B, if there's an A on the other side of the card, it's just fine. The rule still holds, right? But if there's a B, the rule says nothing about if there's a B on one side of the card, then there's a 3. So it's irrelevant. And the final one is irrelevant as well. So it's only about 10 to 20% that are able to choose the falsification card, the 7 card here, while most people will definitely choose the A card. So here's a variation of it where it becomes a social rule instead. And then we are so much better at it. Everyone is. At least everyone with an intact brain. So at the MR department, one has to pay to the coffee box in order to drink coffee. And below are 4 cards. On one side of the card is revealed whether the employee drinks coffee. On the other side, it is revealed whether the employee pays to the coffee box. So this department has the following rule. If you drink coffee, then you have to pay to the coffee box. And which card or cards are necessary to check whether the rule holds. And this is the exact same as you saw in the previous slide. And so the A card, right? If you drink coffee, then you have to pay to the coffee box. The A card drinks coffee because we have to check, let's check whether they, pay to the coffee box or not, right? And the falsification card, which is so easy now, this corresponds to the 7 card before. That was difficult, but now it's so easy. It's, of course, the one that does not pay to the coffee box because we have to check if they drink coffee, right? Then they're breaking the rule. And it's obvious to us also that it is irrelevant to look at the person that does not drink coffee. Doesn't matter if they pay or not, right? And the person that pays to the coffee box, it also doesn't matter if they drink coffee or not. Because the rule only says if you drink coffee, then you have to pay to the coffee box. So this experiment was done in the scanner, right, with a bunch of, social rules and non-social rules actually, but that we are equally good at. It's called precautionary rules where we avoid danger. I'll give you some examples here. So this is an example of a social rule. If you drink alcohol, then you have to be over 18. And which cards do you have to turn? Right? The one where you drink alcohol and the one when you're not over 18. Right? It's pretty obvious that the others are irrelevant. That's a social rule. That's what they have to choose in the scanner. And then there is where people are similarly good, even though it's not social in a sense. It's more about avoiding danger. So it's this one. If you work with viruses, then you have to use safety equipment. And of course, it's again easy to see that we have to check the one that works with viruses and the one that does not use safety equipment. The others are irrelevant. So since people are as good, equally as good at these 2 kinds of rules, then you can compare them. And previously, actually, someone did do a study comparing these rules, but did it with someone who, with both normal human subject with intact brains, but also did it with someone who had a major motorcycle accident and really destroyed parts of his brain. And what is marked with white here is what has been damaged is his brain. So if you look at the left image, you can see some frontal parts. Um, and in the middle image, you can see also some medial, the lower prefrontal parts, and then some temporal parts to the left. And the final image you should ignore because this is the eyeballs you also see. So nothing happened to his eyeballs. But you can also see further in the left side here that his temporal lobe, you can't see it here, also part of his amygdala was damaged. And this particular patient was as good as everyone else for these precautionary rules about avoiding danger, but very, very bad at these social rules. So for some reason, these particular lesions um, or this particular damage to his brain, they influenced how good he was at detecting social tiers on this particular task. So the idea is if we put a lot of students in the scanner, right, and give them some rules, um, of some of these rules, a lot of these social rules and these precautionary rules, and then we compare them, and then we compare them in a very primitive way, just saying, well, we look at all the brain activity that was active, all of the areas of our brain that was active when they did the social rule, and then we simply subtract all the brain activity that was there when they did the precautionary rules. And hopefully, what we're left with, at least that was the hypothesis, what we are left with are those areas that are more active during the social rules, right? Identifying the potential cheaters of the social rules. And the hypothesis was that this would be the exact same areas that were damaged in this patient that had underwent this motorcycle accident. So that was the hypothesis. And what is marked in green here was some of these areas that were extra active during the social rules compared to the precautionary rules. So now I would want to give you, yeah, you can't really do this. This was supposed to be in class. So I'll just tell you about it anyway. You can't really feel it, or maybe try to imagine it, try to visualize it. So imagine you're doing a game, an ultimatum game, and imagine you could just be doing it with me then instead of someone else if you're sitting at home. And so pair up, and one player gets 100 kronas. So there's only a two-person game, and in this situation, I get the 100 kronas. So I have those 100 kronas. You have nothing. It's a one-shot game. And what I have to do is I have to offer you at least 10 kronas. I just have to offer you at least 10 kronas. And if you accept it, right, you that had no money in the beginning, if you accept it, we both walk away with the money. So if I offer you 10 kronas and you accept it, then I walk away with 90 kronas and you walk away with 10 kronas. But if you reject it, we both walk away with nothing. Those 100 kronas disappears in this situation. And there's no negotiation and there's no negotiation and no communication. So the only thing I have to do is just say an amount, and the only thing you have to do is just say yes or no to that amount. So what I'll do now is that I'll offer you 20 kronas. So if you say yes, you walk away with these nice virtual 20 kronas, but I walk away with 80. And if you say no, we both walk away with nothing. And of course, this is not the common thing, the common way of doing it. The most common thing here is that I would offer you 50 kronas. That's what most people do in the Western world in this game. Offer half, and you would accept half, right? But in this situation, I only offer you 20 kronas. So I know that some of you, at least some of you, would reject those 20 kronas from me. And I know some people will say, yeah, that's irrational in a sense, because why, 20 kronas is better than nothing. But some of you will reject those 20 kronas. And if you do, what you're doing here is called altruistic punishment. You're simply punishing me for being unfair, right? I told you this is a one-shot game, so we're not playing it again. But imagine that you're interacting with the same person again, or interacting with me again. If you rejected that offer, the next time we would play with each other. If there was a next time, I would of course offer you more, right? So you're actually teaching me something by rejecting my offer. And it's called altruistic punishment. It's called altruistic because you're actually giving up money. You're giving up your 20 kronas, and you're doing it to punish me. So I would lose 80 kronas, and then I can learn it. And then, I hopefully will learn something from it, learn to be less unfair. So that's the ultimatum game. And this has been done in the scanner as well. You can see here the part of the figure marked A, and you can see they lie there in the scanner, look at the fixation cross for 12 seconds. Then they see a picture of a human, and then they're being told that she gets $8, that she decides, of course, that she gets $8 and you get $2, and then you either accept or reject it. And in this situation, you can see that you rejected it, and we both walk away with nothing. And then the A part, you can see a diagram of what the decision were, right? So the black one columns are when you get it from a human, or you're being told that you're playing with a human. And you can see the acceptance rates on the y-axis, and you can see, yeah, if it's 50-50, 100% accepts it. And then it's slightly less, maybe 95, when it's 7-3, and then it's only 50%, right? When you're being offered, about around 50%, when being offered only 20% of the total, so $2 in this sense. And it gets even less, about 40%, if you're only being offered 10% of it, or $1 in this case. So quite fascinating study, even though it's an old one. It's a really fundamental one. And what I find very exciting as well here is that the humans participating in this study, and there's nothing to say that we wouldn't be similar, it's actually also sometimes rejected offers from a computer, which is quite extraordinary, right? I mean, if I open my computer and the computer said, "Well, I'm going to give you $2," I would probably say yes. And also because I mean, how would I imagine my computer would learn anything if I said no? So it speaks into a broader issue about whether we humans can actually understand anonymity. It seems to be, at least according to this study and also other studies, we could discuss this, that we don't really understand that we are interacting with someone anonymous, or with a computer, that we can't help but ascribe intentions. I mean, even to dead objects like a computer, or artificial objects like a computer, or maybe artificial intelligence. But this is definitely something I can't just talk to you right now alone. We would have to discuss it in class. We'll do that at a later period. Here is some quite fun, I think, sex difference. So this is Tanya Singer back in 2006, where you can really do fun experiments. And this was done in Switzerland. And she would actually give subjects real electric shock, which is quite fascinating. I mean, of course, it's not anywhere near deadly, but it's just painful electric shocks. And so imagine that you've been playing another human that would keep on cheating you in a social, in a game, in an economic game, and keep on trying to treat you unfairly. And then how would you react if they received an electric shock? And what we saw here is that, and divided into women and men here. If you look to the left, you see an image where the nucleus accumbens is highlighted. This is an area of the human brain associated with the euphoria. This is the area where cocaine really exerts its influence. And so yeah, I guess you could all, and us, and yeah, sex and other things that can give you euphoric feelings associated with the activity in nucleus accumbens in the reward system. And we can see here that the men in this study certainly had an elevated activity in this area when they saw cheetahs get electric shock. And women didn't, and we can't really interpret. I mean, negative activity, it doesn't really happen. So the most important part is just to say that yeah, men had more, at least, activity in nucleus accumbens than women when watching, observing these cheetahs get an electric shock, and also reported a higher desire for revenge. And what is not shown here is that women then reported a higher feeling, more empathy actually towards the perpetrator here, the cheater. So maybe this has something to do, or maybe this relates to the fact that men seem to enjoy certain kind of action movies where people are killed, and the bad guys are killed in disgusting ways more. I don't know. This is also something we can discuss. Finally, the next to final slide here. Um, this is just my experience throughout the years, what I've took with me in terms of the pro-social brain, that we really do have a super pro-social brain because we engage in altruistic reward, right? I mean, we people enjoy giving money to charities, even anonymously. There is some kind of, yeah, we like to reward others for good behavior, right? I mean, if we go to a theater and everyone is great, and it ends, then we clap, right? I know it's also a social rule, but we like we like to reward others for what we consider good behavior or pro-social behavior, right? And we also engage in altruistic punishment, as we just did. So we punish others for bad behavior, which is also very pro-social. Um, and we also really enjoy successful social cooperation. And what these three types of behaviors have in common is, again, activity here associated with the striatum in the middle of the human brain, sort of, yeah, a little bit behind the lower parts of the prefrontal cortex in the reward system. Our brain simply rewards us for these kinds of behavior, and I think it's something to celebrate. So, finally, thanks.